going to do a quick little demonstration of what we can do with fields. So I'm just going to get from the browser, content browser, I'm going to go down to bipeds. I'm just going to use this guy. I'm just dragging this human body. He's super big, so I'm going to make him smaller. Just make him 0.1. There we go. So just got this man in the scene. So I'm going to create a graph. I'm going to drag him in like that. Now I'm going to convert into a volume, and one of the things about when you convert things to volumes in Bifrost is that that volume gets calculated every frame, which can make everything go very slow. There's a way around this, which now that we've got this sort of newer version of Bifrost and we've got the sort of graph nodes, we can basically make a graph, which I've done. I'm going to convert him into a volume. So I'm going to go convert to volume and just plug in the geometry. Let's click on that. Want to make sure I've got store level set on. That's going to be important for the next bit. Resolution, I'm going to put to absolute, and I'm going to do optimized, so it's going to sort of do it a bit quicker. And then I'm just going to output that out, and we'll get that. So this is the level set. This grey thing is the sort of level set of the voxelized character. I'm just going to drag out my mesh as well into there. So I'm outputting my volume and my mesh. So with that done, I can actually, well, we'll just leave that for a moment. I'm going to make a new graph. I'm going to drag in this one. Now I can just hide that. Don't need to see you anymore. I'll leave the human body there for the time. So what's good about doing it this way is that now this won't get recalculated every frame. It's calculated to begin with, but because we're outputting it back to Maya, it's now using the Maya world of caching. And the Maya world of caching says don't recache unless there's a change. And there isn't a change in here. It's just going to stay exactly the same. Whereas if we just done it in here, then continued on making my graph in here, it will cache this, or evaluate it, should I say, every frame. So it will slow it down. So this, by dragging this into here, this now will only evaluate once, and it will make it a lot quicker. So that's a good little tip. Other good tips for speeding up, I think I mentioned before, but turn off resumable unless you need it. That speeds up simulations. Right, so I've got a volume of the mesh, and I've got the mesh. So first thing I'm going to do is I want to make a voxel field of this guy. So I'm going to go tab, voxel field. By default, it makes a thing called a signed distance field. And what a signed distance field is that basically if I go to scalar field scope, and let me just delete that, do a terminal. So if I plug that into there, and we plug that into there, we get that, which is a bit, ooh, what's going on there? I might just do my minimum bounds to 0 and do that as 20. So what's happening here, if I make these point sizes smaller, even smaller, even smaller, there we go. So these are all values. So say this is, well, they're all getting slightly bigger. You can't really necessarily notice it, but when you go inside, you can see as they get closer to the surface, they get smaller and smaller, which means their value is less and less. So basically at the surface, the scalar field value is 0, and as it gets further and further away from it, it goes up and up and up, so it gets more and more value. So you basically got this sort of gradient value from 0 onwards, coming away from the body. And this can be super handy in all sorts of ways. So, got that. I'm going to make a turbulence field or a noise field. I'm just going to make I'll make a fractal noise field. There we go. And this is another scalar field. You can see if you mouse over that, you can see written down there. It's a scalar field. So if I plug that in, you would see those back up to something bigger. Oops, quite cool. All this stuff's renderable, by the way, if you quite enjoy making these sort of things. If I do that to 100 and put that to 0.1, 0.01, 0.5, sort of similar, 50. I'm just trying to show you, this is basically just noise. It's a fractal noise field in the scene. Do that 0.1. There we go. So you can sort of see it's sort of noisy in bits. So the bigger the particles, the more value is in there. So this is a noise field. So I've got my voxel field, which is a gradient going from 0 and getting bigger and bigger as it goes away from the object. And I've just got this general noise field. Now, I want to make this not just a value, and this one not just a value. I want to make them into vectors. So if I make a gradient field, and what a gradient field does is it converts a scalar field into a vector field by saying that 0, so the values that are low at 0, they're the sort of beginning of the vector, and the higher values are the end of the vector. So it's like a sort of, it makes it into sort of slopes and hills, as if you could imagine that. So the higher the value, the higher it is as a slope, as it were. Slightly confuse that, but you sort of get the gist. Anyway, basically it makes it into a vector. And I also want to do the same for this one. So I can just duplicate that and plug that in. So now if I make a vector scope, the field scope, plug that in. Let's make a new one of these. We'll plug that one into there. Let's turn that one off. Let's just move him up as well. And turn on flow lines, because this just gives you directions, whereas you want to see the flow over time. So this has now converted that into vectors, so you see all those little lines of directions and movement. And the same with this one. So this one you can now see, if I plug in the probe geometry, it will make more sense. These are now vectors flowing away from the object, and they're different to normals because you can see when they get up to each other, when they sort of intersect, they sort of bend and sort of flow into a path. Right, so I've got these two things. Now this is where it gets a little bit complicated because there's a bit of maths going on, which I don't fully, I sort of understand it. I couldn't tell you how to work it out mathematically, but we're going to do a cross product of these two. And what a cross product does is it takes two vectors and it works out the one that's a right angle to them. So it takes the two of them and then works out a right angle. So if I go cross, and that. So if you sort of look at the icon, that's the two vectors, and that's working out the right angled vector to the both of them. So I'm going to put the fractal noise field into the first one, and the order of these is important, and the gradient of the voxel field into the second one, and I'm going to plug it into there, and we get that, which is pretty cool already. So what it's done is where the noise field and the voxel vector field are at the same point, it's working out the right angle of that, and basically it means that because they're going out and that one's going that way or wherever it's going, it's gluing them to the surface, it's sort of laying them over the surface, so you get this really cool pattern of vectors on our little guy. And as I say, these are renderable, you can render these if you wanted to. So, got that. So now what I want to do is I want to make a particle system, and I want these vectors to sort of control the movement of that particle system. So let's make a basic particle system. Basic. Let's explode it. And I want my, let's just move that out a bit. I want my mesh. So I'm going to click on that, hold down middle mouse, put that into geometry. We're going to emit from that. We want to turn off gravity, put these to disks. Going to turn off or turn on live forever, no speed, and then let's plug it into one of these terminals as a proxy, like that. So we should see some particles now. Let's turn off that guy. I just want to make these face the camera. So now when I hit play, they just grow onto the body, which is fine. So I've got that. I've got a body of particles. So I want to put this as a force affecting these particles. So if you remember from the other video, if I type in force, I get set influence force. I can plug in the cross product of that into there, like so, and then just plug that into my influences. And now when I hit play, we get that, which is not quite what I want. So first of all, once it's getting the velocities off the force, it's sort of going off its own way. I just want it to keep those velocities that are on the influence. So if I make a drag, influence, and I plug that into there, and let's see what happens at 10. So now when I make the particles a bit further away, I'm going to get that. So sort of sticking to the body, but they are still now moving off a little bit, which is not what I want. So I need to sort of mask these areas around it, and what I can do is, we know that this voxel field, the value of 0 is at the beginning, and as it gets further away it gets to 1, 1, 1, 1 and bigger and bigger. So it's like a gradient leaving the body, as it were. If I make an F-curve field, we haven't really looked at F-curves, but they're a way of interpolating values using a curve, and there's a evaluate F-curve in the non-field world of Bifrost as well, which you can use, which we may look at in later lessons. So if I plug that field in, and what you get is you get this, doesn't look very interactive, but if you click it, you basically get a curve you can play around with. You can click on these, get presets, that's a default, which is just 0 to 1. I actually want to flip this. I want 1 to be at the surface and 0 to be further away. So I'm just going to go presets and flip. So it's going to flip that. And what I want to do now is I want to multiply that over the top. So if you think about it now, this values of 1 right near the surface, but as it goes further away it gets less and less to 0. So if we know if you multiply something by 0 you get nothing. So everything that moves further away from this field, this turbulence field, will get less and less power. So if I now plug that in, that, and try that, and let's just hit play. Actually what I'll do is, so it makes a bit more visual sense, I'll just only emit them on frame 1. So now they're sort of moving around the object. So if I unhide our guy H, they are slightly coming off still. Let's try doing, maybe put that to 50. Sticking a little bit more. And I can go to my F-curve and I can bring in this 0 to a closer position. So if I go 0.2, it will sort of clamp down the zero aspect quicker. So there we go, they're sort of just sticking. They're moving around, but they're sticking to the body. Maybe I can put that back to 20, see what happens there. Yeah. So that's really cool already. That's actually a really difficult thing to get to do, is to sort of stick particles to a surface like that and move them around. Right, so we've got that. I'm just going to introduce you to another cool thing, which is, we haven't talked about strands, but we will do. They are a really cool thing in here that you can make very quick lines, basically. They're just basically lines, but you can make hair out of them, all sorts of things. You can also make particle trails. So I'm going to do, just type in trails, and it is create particle trails. So I get this, it's one of the Rebel packs, so you need that installed. Number of frames it exists for, I'm going to do 500. I'm just going to plug that into there. And, well, let's just have both for the time being. And then let's just hide you. So, now, when I do that, we're drawing out the man's figure with little lines, which I think is really cool. And you can go back, we can play around with, let me just do this. Oops. Sorry, back to perspective. We can go back to our turbulence field, put that down to sort of 1. And going a bit slower now, so let's put that to 5. So you can play around and just change all the settings of the noise, and you'll get a whole sort of different. And if you've not got enough particles to draw it out in the way you'd like, just go back here and let's just crank that up to say 1,000. And if you don't want to see the particles anymore, we can just unplug them. So let's try that. There you go. I haven't yet experimented with doing this on a moving character. So I'm not sure how that would work, but it works pretty good on static stuff. If you want to draw lines and things over it, or just draw particles. That's pretty cool, isn't it? And then if I wanted to, didn't quite think that was good enough, I could go back here. It's maybe 2, 1. Just play around with these. Maybe let's try 2 just to see how crazy it looks. Oh, yeah, that is a bit crazy. Yeah, weird sort of stick man. Let's try 0.8. Let's try 1, but take that down to 2. See what happens. There we go. So that's pretty cool. So that's that. Let's just go through the thing one more time. Oh, it's all laid out. Right, so let's just squeeze him over, get rid of this. So, first things first, in this graph, brought the human body in, convert to volume, make sure you turn on level set. I put that to absolute and optimized. Output it like that. I've output the mesh as well. In here, we drag that graph in, so we can hide that graph now, we don't need to see it. This will only get evaluated once, so we don't have to do it every frame, and that's why we've done that. Mesh into the particles. We are volume as a voxel field, don't have to change anything in here. Add a gradient field, make a fractal noise field, added a gradient field to that to make it into a gradient or into a vector. Then we cross these two, and this is a cross product, which basically gives you a right angle. It's weird that when you put that in, it changes. And you want to put the noise field first, voxel field second, and then we've taken the voxel field into an F curve, which we flipped, which you can do by clicking on that, going there, and flipping there. And I took that value down to 0.2 to keep it nice and close, which I then multiplied over the cross product. That goes into our influence force. We've added a drag to that to make sure that the particles are only using the velocities of this. And then we've got our basic particle setup, just turned off gravity, turned it to disk, only emitting on the first frame. If you emit on multiple frames, these strands will go a bit peculiar, so if I can show you that now, because they rely on having a fixed number of points when they're generated. So you get that. So there are ways around that, but they're quite complicated and slightly beyond my skills. So yeah, just make sure you only emit on the first frame. Simulating particles. What else did I turn off? Turn on live forever. Make sure there was no speed or anything on them. And then create particle trails. Put it up to the length of the frame, and output is that. In the next video, I will quickly show you how to render strands.